Alright, today we are going to talk about inverse function. But before we move on to that, let's recall what is a function. Let's say we have a function 2x plus 3. Alright, make sure you know that this x, right, we call it as object, and this x is also object. Alright, this particular x is also object. This x, right, and this x, they are linked. So which means if I change this x to another number, let's say w, this x also becomes w. Alright, if it becomes like j plus 2, so this x also will become j plus 2. But this 2 and plus 3, right, will remain. Alright, only these two x are linked. So this 2x plus 3, right, the whole package, we call it as image, the whole package. Single x, object. Whole package, image. Okay, we can imagine a function as a machine, in which if we put in x, right, to be an object, we will get back 2x plus 3 in the end, alright, which is the image. So the process of making this x into 2x plus 3 is as follows. Let's say we have an object, x, alright, we will first multiply it with 2, as you can see here, multiply it with 2 to get 2x, and then we will plus 3 to make it into 2x plus 3. So at first we will put in x, and then we will have all these calculations to make it into 2x plus 3. So if I replace this x with a number, right, let's say I replace it with 5. So this 5 will be first multiplied by 2 to become 10. And then it will be added with 3 to become 13. So this 5, right, we call it as object, and this 13 we call it as the image. Alright, same goes for the x and the 2x plus 3. The x is the object and the 2x plus 3 is the image. Okay, so an inverse function is actually like a machine that helps you to transform your image back to the object. So in other words, right, if I put this 13 into this inverse function, it will change this 13 back into 5. Okay, so to achieve this, we will have to inverse all the effect that has been done to this 5 to make it into 13. Okay, so one analogy that I like to use is the pooping process. Okay, mainly because we are doing it every day, hopefully. So I guess it will be quite relatable. So let's say right now you feel like you want to poop. Okay, the first step that you are going to do is to take off your pants, right? And then you will take off the underwear. And then you poop. You poop. Okay, so I believe this is the process for most of the people. So we can imagine this as a function from the original state to the state you poop. So what will be the inverse function for this? It will be going back from this state all the way back to your original state. Alright, and the sequence will be this. You have just excreted, alright, and now you are going to stuff it back into your body, put on the underwear, and then you put on the pants and act like nothing happened. Now you're at the original state again. Alright, the key is not about how you stuff it back into your body, alright? We are trying to focus on the sequence. If you want to go back to the original state, right, the sequence is important. You are going to put on the underwear, then only the pants. And you're not going to do it another way around, right? So the last step in your function is going to be the first step in your inverse function. So come back to this example. So if I were to change this image, right, back to its object, I will first minus by 3. Okay, you inverse the effect. Just like here, you take off. For inverse, you put on. So here plus 3. So for the inverse, it will be minus 3. Okay, so we are taking the image and then we minus it by 3. And then for the function, right, we see is multiplication, multiplied by 2. So if we are trying to inverse it, we need to divide by 2. So in the end, we will have image minus by 3 divided by 2. So this will be the original object. Okay, so the inverse function is the process of changing this image from the beginning all the way back to the object. Now this image minus 3 over 2 is the object. So we can write this in the equation form, in which it will look something like this. Okay, we're going to put this image into an inverse function. Let's call it f inverse. This is just a name that I gave it. You can give it as a g or h, any kind of unknown that you like. But giving it as f inverse, we show that it has a certain relationship with the function f. So by the time you look at it, you know that this f inverse, right, is the inverse function for f. Alright? Okay, so what happens is that if I put this image into the inverse function, this image will be deducted by 3 and divided by 2 to get back to its object form. Okay, this image is just an unknown to represent all the possible numbers. Okay, all the possible numbers. So it can be 13 if you put in 5 as object. So it can be other numbers, depends on what object you put in at first. Since it is just an unknown, that's why we can choose whatever alphabet that we like to use. So in maths, usually we will just standardize the unknown. So let's say your function f is using x, then we just use x as the unknown. Alright, so let's say we want to find the inverse using equations. Okay, what we need to do is to let this 2x plus 3 to be an unknown. Alright, why? Because we know that this 2x plus 3, right, in the end is going to be a number. In this case, it can be 13, it can be other number as well. So since we don't know what is that exact number, so we give it an unknown. Alright, we will know what is the number if we know what is the x here. But now this x is an unknown, we don't know what is the image. That's why we leave the image as unknown as well. Alright, this is why you can use any unknown, no problem. So the effect of reversing, right, all this effect that has been written at here, okay, can be done by actually removing all these 3 and 2 away from the x. Okay, so if I shift this plus 3 to the right, I'm like doing what I have done on the left example, whereby I'm using the image to minus 3, and the same goes for dividing the 2. Alright, shifting the numbers away from the x is like you're doing all these steps to get back to the object. So your object x is equals to image y minus 3 over 2. Alright, in the end, we can write in this form again. So in this case, we have defined the image as y, so we can say when we inverse the image y, alright, we will get back its object x, which is equals to y minus 3 over 2. And since the unknown for the image can be anything, we can change back to any unknown that we like. In this case, we can change it back to x, so to standardize all the unknown, and we have x minus 3 over 2. Alright, so these are the steps that you need to do in your exam to get the marks. So next time when you're solving any sort of inverse function question, you just need to let your image to be an unknown and then shift away all the numbers from your x. After shifting all the numbers away from your x, you will get your final answer. Alright, that's all for today's lesson. Don't forget to hit the thumbs up and also subscribe to my channel. And I will see you next time. Bye.